Myself, Dr. Somit De, teacher in charge and assistant professor of mathematics section under Department of Basic Science and Humanities, Asansol Engineering College. This is my lecture number 4, the continuation of that is a continuation of last lecture, that is lecture number 3. I had discussed evaluation of definite integrals. I had described some properties as well as some problems. In this lecture, I will solve some problem based on this previous properties, previous lecture based on definite integrals. Paper name Mathematics 1A, paper code BSM-101. This is lecture number 4 under module number 1. Topic is evaluation of definite integrals, calculus, integration. This topic belongs to this volume name, module name. Evaluate 0 to 2 mod of x square plus 2x minus 3 dx. So already you know mod x can be expressed as a positive form and negative form. So x square plus 2x minus 3, this can be written as a factor wise x plus 3 and x minus 1. So from here it is clear, when your x value, that is minus x plus 3 into x minus 1, when your value of x lies between 0 to 1. Okay, and then so x plus 2, x plus 3 and x minus 1, when your x lies between 1 to 2. Okay, so this, now you can divide. Now how to decide this range, because your range 0 to 2, so that's why I dividing this. Okay, now 0 to 2, so mod of x square plus 2x minus 3 dx, you can divide this 0 to 1, x square mod of x square plus 2x minus 3 dx, plus 1 to 2 mod of x square plus 2x minus 3 dx. So already you know, in this 0 to 1, this is the negative form, that is x square minus 2x plus 3x plus minus 3, that means you can write as a negative. And 1 to 2, x square plus 2x minus 3 dx, very simple. Now integrate this x cube by 3 plus x square minus 3x, and from here 0 to 1 plus x cube by 3 plus x square minus 3x, 1 to 2. So if I simplify this, minus 1 by 3 plus, if I substitute the upper limit and lower limit, what you have, that is 1 by 3 plus 1 minus 3. If I substitute here 1, so 0, ultimately 0, so minus this. If I substitute the upper limit, that is 2, that is 8 by 3 plus 4 minus 6, from here minus of lower limit, that is 1 by 3 plus 1 minus 3. Ultimately what we have, that is 2 into 5 by 3 plus 2 by 3, that is after simplification you have, that is the 6, that is 10 plus 6, 10 plus 6, that is 10 plus 2, that is 12 by 3, that is 4. 4 is the answer. Question number 2, same type example, 2 to 4 fx dx, where fx equals to mod of x minus 2 plus mod of x minus 3. So we have fx 2 to 4 fx dx is equals to 2 to 4 mod of x minus 2 plus mod of x minus 3 dx. Now, so already you know that here try to understand the logic behind this. So what we are doing, be careful about this. 2 to just to check 2 to 4 as it is, and this 3 2 to 3 mod of x plus x minus 3 dx, 3 to 4 x minus 3 dx. Okay, so already you know, since x minus a is equals to x minus a if x positive, greater equals to a, and x minus a is equals to minus of x minus a if x is negative. Okay, so here ultimately full value is above 2, so that's why 2 to 4, no negative part, no lower than part, so that's why you should directly you can write positive 2 to 4 every time. This x minus 2 always positive, mod of x minus 2, so that's why I'm writing x minus 2. And here 2 to 3, this is negative, that is less than 3, so that's why 3 minus x, and 3 to 4, that is here your fx is positive. That is a mod of x minus 3 is positive, so x minus 3 using this property. Now simplify, very simple example, just you have to remember what about the value factor wise, what is the value you have. So according to that you have to change the integration and divide the integration, and according to that you have to substitute the positive value or a negative value. So from here you may write x square by 2 minus 2x 2 to 4 plus 3x minus x square by 2 2 to 3 plus x square by 2 minus 3x 3 to 4. Clear? Upper limit minus lower limit. 8 minus 8 minus of 2 plus 4, that is from here 9 minus 9 by 2 minus of 6 plus 2, and upper limit this one minus of lower limit, plus similarly 16 by 2, that is 8 minus 12 minus of 9 by 2 plus 9. After simplification what you have, 8 8 cancel, 2 from here, these are 12, 2 plus 2 4, this also cancel. Ultimately if you simplify you have a 3 result. Okay, so this also another very good question for you. Minus 2 to 2, 1 minus x square dx. Okay, minus 2 to 2 mod of 1 minus x square dx. So minus 2 to 1, 1 minus x square dx plus minus 1 to 1, 1 minus mod of 1 minus x square dx, 1 to 2 mod of 1 minus x square dx. So minus 1 to 2, this should be a negative. So that's why you have x square minus 1 dx, minus 1 to 1, 1 minus x square positive. So that's why you have this 1 to x square whole square, and 1 to 2 as it is positive value. One to 2 negative positive value, that is x square minus 1 whole square. That is from here x cube by 3 minus x plus x minus x cube by 3 minus 1 to 1 plus x cube by 3 minus x 1 to 2. Simplify this, upper limit, that is half 1 by 3 minus 1 by 3 plus 1 plus 8 by 3 minus 2. So from here we are getting, that is 7 by 2 minus 1, that is 4 by 3, and 1 minus 1 by 3 plus 1 minus 1 by 3, that is 3 by 2 by 3, 2 by 3 into 2, that is 4 by 3, and from here 8 by 3, that is 8 by 3 minus 2 minus of 1 by 3 minus 1. Ultimately you have 4 by 3. So therefore ultimately your result is 4. This is also another, now this is also very good question for you. 1 to 2 root under x by root under 3 minus x plus root x dx. Let I is equals to 1 to 2 root x by root 3x minus 3 minus x plus root x. Now we want to apply this property, a to b fx dx is equals to a to b f of a plus b minus x dx. So write down, that is I is equals to 1 to 2, that is 3 minus 1 plus 2, that is 3 minus x root under x plus root under 3 minus x. If I add 1 and 2, I plus I is equals to 1 to 2 x plus root under 3x, x plus root under 3 minus x. So try to understand the logic. So if you have this type of problem, then only you can express into this form. Another part, you have to check what the value you have. If I add these two, can I generate this value? If yes, then only you can apply this property, otherwise not. Ultimately these two are cancelled. So 2i is equals to 1 to 2 dx is equals to 1 to 2 1. So I is equals to 2 to 1 to 2 root x by root under 3 minus x plus root x dx is equals to half. This is also very good example. Without practice it is very difficult. So what are the key points? Just you have to check upper limit and lower limit. If I add these two, which is equals to this, yes or no? If yes, then you can apply this technique. Next, this is also very good example. Find minus 2 to 2 log of 1 x plus root under x square plus 1. Let fx equals to log of x plus root under x square plus 1. F of minus x is equals to log of minus x plus root under x square plus 1. If I take minus sign, that is minus of log x, that is 1 by root under minus x plus root under x square plus 1. So if I rationalize this, that is minus log of x plus root under x square plus 1 by x plus root under x square plus 1 into minus x plus root under x square plus 1. If I simplify, what we have, that is x plus root under x square plus 1 by minus x square plus x square minus plus 1, that is these two are cancelled. What is left, that is minus x log of x plus root under x square plus 1, which is nothing but minus fx. So from here it is clear that f of minus x is equals to minus fx. So that means your function fx is equals to log of x plus root under x square plus 1 is an odd function. So already you know, if your function is odd and your upper limit and lower limit, your middle point is 0, then we can write minus 2 to 2 log of x plus root under x square plus 1 into dx is equals to 0, because your function is an odd function. So this is also very good example for you. Another, minus half to half cos x log of 1 minus x by 1 plus x dx. Let fx is equals to cos x log of 1 minus x by 1 plus x. Now f of minus x is equals to cos of minus x log of 1 plus x by 1 minus x. Already you know cos absorb the negative sign, so cos x log of 1 minus x 1 plus x whole to the power minus 1. You have a unique property of logarithmic. So this minus 1 you can take outside. So that is minus x is equals to log of 1 minus x by 1 plus x is equals to minus fx. So from here it is clear that the function fx equals to log x cos x log of 1 minus x by 1 plus x is an odd function. So therefore we have minus half to half cos x log of 1 minus x by 1 plus x dx is equals to 0. So sometime you can find this type of question without any calculation. You can find the answer if you can prove that your function is an odd function. Then the property wise, that is extension part of property number 7, we can prove the result is 0. Now this is also very important question for you. So in my last lecture I had discussed one example with under root under sin x, root under sin x plus cos x. So here it is a square root is replaced by only sin. Okay, try to understand same logic, same clarification. Let I is equals to 0 to pi by 2 sin x by sin plus cos x dx. Now I is equals to 0 to pi sin x by sin x plus cos x dx. 0 to pi sin pi by pi minus pi by 2 minus x sin of pi by 2 minus x plus cos of pi by 2 minus x dx, because since 0 to a fx dx is equals to 0 to a f of a minus x dx. So I had solved one question in my last lecture, you can check. So from here it is clear that is sin of pi by 2 minus x is equals to cos x, and cos of pi by 2 minus x is equals to sin x. So ultimately what we are getting, that is I is equals to 0 to pi by 2 cos x by sin x plus cos x dx. So if I add this and that, then you have 2i, that is I plus I 0 to pi by 2 sin x by cos x plus sin x dx plus 0 to pi by 2 cos x by cos x plus sin x dx, 0 to pi by 2 sin x plus cos x by sin x plus cos x, these two are cancelled. What we have, that is 2i is equals to 0 to pi by 2 dx is equals to pi by 2 after integration. Okay, so therefore I is equals to 0 to pi by 2 sin x by sin x plus cos x dx is equals to pi by 4. This also very good example for you. Just you try to memorize or try to understand. So if you have a sine type cos type, if I replace this, there is no change. So already you know from the trigonometric point of view, sine and cosine, they are connected to each other. Just revert sine of pi by 2 minus x is equals to cos x, and cos of pi by 2 minus x is equals to sine x. So this is a vice versa type. So that's why. So already now basically this all are defined in the first quadrant. So that's why in first quadrant all are positive. There is no change. Okay, so this type of question you can expect in your question paper maybe. So try to solve similar type of question. Okay, very easy. The root under sine x, root under sine x plus root under cos x. So here what is the basic difference? Only I replace square root, nothing else. This also very good question. Evaluate 0 to root 3 tan inverse x 2x by 1 plus x square into dx. This is also very good example. We know that tan inverse x 2x by 1 plus x square is equals to 2 tan inverse x when your x lies between minus 1 to 1. Minus 1 to 1. And is equals to minus pi plus 2 tan inverse x when x positive. So what is the key point, key line? So your key line is this. Your tan x is lies between minus 1 to 1. So here you may write this expression, that is this expression is lies between minus 1 to 1. So you may write minus tan inverse of 2x by 1 minus x square is equals to 2 tan inverse x when minus 1 less than x less than 1. Correct? And minus pi plus 2 tan inverse x when x is above 1. So according to that, we can divide this range, that is 0 to root 3 tan inverse 2x by 1 plus 1 minus x square dx is equals to 0 to 1 tan inverse 2x by 1 minus x square dx plus 1 to root 3 tan inverse 2x by 1 minus x square dx. So from it is clear that is 2 0 to 1 tan inverse x dx plus 1 to root 3, that is minus pi plus 2 tan inverse x dx. So you basically you have, if I can take common 2 0 to 1 tan inverse x dx plus 1 to 3 tan inverse x dx minus of 1 to root 3 dx. So you may write so ultimately 0 to 1 and 1 to 3, that is 0 to 3. So that's why you have 2 0 to 3 tan inverse x dx minus root 3 minus 1. So tan inverse x tan inverse x, the formula 0 to root 3. This is also very good formula. Please memorize this. Minus thus using by parts 2 into x tan inverse x 0 to root 3 minus 0 to pi by root 3, that is minus 2x by 1 plus x square into dx minus pi root 3 minus 1. Your pi is missing. You should write here pi. So I should write pi. Pi is missing. Typing error. Now if from here it is clear, that is root 3 by minus pi by 3 and is 0. So minus, this is log. If I take log, that is a log of 1 plus 1 plus x square. Derivative of this is 2x. It's obvious. So 0 to root 3 minus pi root 3 minus 1. So from here it is clear, that is 2 pi by root 3 minus log 4 minus pi. Log 1 is 0, that is minus pi root 3 by root 3 minus 1. That is pi minus pi by root 3 minus log 4. If I take common, that is pi common, 1 minus 1 by root 3 minus log 4. Okay. Very good example. Next, this is also very good example for you. Same logic, 0 to pi by 2 a square cos square x plus b square sin square x is equals to prove that pi by 4 a square plus b square. Let I is equals to 0 to pi by 2 a square cos square x plus b square sin square x dx. So I is equals to 0 to pi by 2 using this property, that is a to b fx dx is equals to 0 to a f of a minus x, because sine cos are sine and cosine you have, so you can apply this technique. That is a square cos square pi by 2 minus x, b square sine square pi by 2 minus x dx. So ultimately what we are getting, that is 0 to pi by 2 a square sine square x plus b square cos square x. Then you have to add both, that is 1 I plus I, 0 to pi by 2 a square cos square x plus b square sine square x plus a square sine square x plus b square cos square x dx. So from it is clear 2i is equals to a cos square plus sine square x, that is 1. So a square plus b square into dx. So ultimately you have a square plus b square pi by 2 after integration. So ultimately you have I is equals to a square plus b square pi by 4. That is I is equals to 0 to pi by 4 a square cos square x plus b square sine square x dx is equals to pi by 4 a square plus b square. Proved. So please memorize, if you have a sine cosine, then there is a chance, there is a possibility to apply this formula. Otherwise you can solve it, but it's become too lengthy. So if you use this property, then it's become very easy to you. Okay. Next, 0 to 1 log of 1 plus x by 1 plus x square dx is equals to pi by 8 log 2. This is also very good example. Let I is equals to 0 to 1 log of 1 plus x by 1 plus x square. Now consider x is equals to tan theta. What is dx? Dx is equals to sec square theta d theta. Okay. So when you that means your x replaced by, so when you replace by theta, when x 0, this is 0, but when you replace 1, this is pi by 4, because 10 is associated with the 10. So that's why. So ultimately what we are doing, that is d theta, all theta should be replaced by sec square theta. So I is equals to 0 to pi by 4 log of 1 plus tan theta by sec square theta into sec square theta d theta. So ultimately you have 0 to pi by 4 log of 1 plus tan theta d theta. So you have a unique property that 0 to pi by 4, that is log of 1 plus tan of pi by 4 minus theta d theta. So this is nothing but, if I write this, then you may write that is log of 1 plus tan theta by 1 plus tan theta, formula wise log a minus b is equals to this. Okay, then log 0 to pi by 4 log of 2, if I add, if you take LCM, you have this, that is 2 by 1 plus tan theta d theta. So ultimately what you have, that is 0 to pi by 4 log 2 theta minus 0 to pi by 4 log of 1 plus tan theta d theta, which is equals to I. So if I transform the left side, what you get, that is 2i is equals to pi by 4 log 2. Therefore I is equals to 0 to 1 log of 1 plus x by 1 plus x square dx is equals to pi by 8 in log 2. This also very good example for your exam purpose. Try to practice similar type of question. This is not a question, this is one kind of property. If fx be an odd function, then so that a to x ft dt is an even function. Since ft is an odd function, so f of t minus t is equals to minus of ft. Let fx is equals to a to x ft dt. So f of minus x is equals to a to minus x ft dt, because you are replacing all x by minus x, putting t is equals to minus j, so dt is equals to minus dz. So therefore f of minus x is equals to minus of minus a to x f of minus z dz. So is equals to minus a to a fz dz, because f of minus z is equals to minus fz, because it's an odd function. So from it is clear that minus a to a fz dz plus a to z my fz dz. So from here it is f is an odd function, so this portion is 0. So a to x fz dz. So from here it is clear that is fx f of minus x is equals to a to x fz dz is equals to a to x ft dt. So that means you here we are replacing only variable, that is z by t. So from here it is clear, f of x is equals to a2x ft dt. So here f of minus x is equals to a2x ft dt, which is equals to fx. From here it is clear, that is fx is equals to capital Fx is equals to a2x ft dt is an even function. Thank you. Try to solve similar type of question.